All right. So, Grant, we've talked about clearances, like when we go over roadways, over fields and parking lots. And, but a question that commonly comes up, is there any difference if we cross a waterway? Does the NESC have different clearances than we cross a road or how's that treated and where's that at in the code?
So we talked about the full day class has all 10 clearance rules. We have a little table and chart. We go through how to find those. But this is the rule. If you open that, look through the code, vertical clearance of wires, conductors, and cables above ground, roadway, rail, and water surfaces. So wires above ground, roads, water. So that's probably where we're looking, right? Vertical clearance above water. There's two places that we want to look in there. One is the Rule 232, and then Table 232.1 has clearances. This is probably the most commonly looked at table in the code. If you've only opened the code once, look for one thing in there. It's a pretty good chance you've looked at clearances above ground, Rule 232. All right. The one thing I want to remind everyone there on 232, we open up, we find that table. We always got to read the text of the rule that references the table so we know how to apply that table. We see a clearance above ground in there. We want to just use that. But if we look at Rule 232A, it's going to give us worst cases for temperature, loading, ice that we have to look at. 32 degrees with ice from your loading district, or a high temperature of 120 degrees Fahrenheit or more if so designed. So just keep that in mind as we talk about these clearances. There's 10 rows in Table 232.1. Starts out with Road 1, railroads. 2, 3, and 4 are all areas with truck traffic. But if we go down to row 6, that's going to be the first one with water. Water areas not suitable for sailboating. So maybe we're crossing a river, a little bit of an edge of a lake where a mountain lake, there's not sailboats up there. This is going to be the row we're looking at, anywhere where there's no sailboats. So this is above water. And then if we look at the columns up there, those are going to be the different cables and wires that we're looking at. There's a lot to sort through there. If we look at that first column, it's got insulated communication conductors and cables, overhead shield surge protection wires, neutral conductors, and supply cables meeting 230C1. So there's a lot to think about there, some rules to look at. But the two we really want to pick out there, communication cables and conductors and messengers, and neutrals are in that first column. So 14 feet if there's no sailboating for your communication, your neutral. The second column, 0 to 750 volts, meeting Rule 230C3. If you go back to 230C3, that's effectively grounded neutral with insulated cables, energized cables around it. So that's your power service drop, your typical triplex, quadruplex, duplex service drop. So your power, 14.5 feet. And then if we skip over to the fourth column, open supply conductors. So remember, supply is power. Open is just the word the code uses for not insulated. It's either insulated or it's open. So your bare power wire up to 22 kV phase to ground is 17 feet. So that's kind of where all those values come from. The other thing when you're looking at these tables, always look up at the headings, look at the columns, find out when it's talking about voltage. Some tables talk phase to phase voltage, and some use a phase to ground voltage. So that 22 kV, I don't have the subtitle up here, but if you look at the subtitle, there's a good paragraph under the heading of the table 232.1. It says phase to ground are the voltages being used. So that's our typical distribution voltages. We're going to have 17 feet. So this is just a drawing of that row of the table. The McGraw-Hill NESC handbook has a drawing for every row in that table, kind of a practical application. Here's what those numbers are. So there's that 17 feet we saw up to the phase, 14 feet for both the communications and the neutral, and 14.5 for our service drops. So if we go down to the next row, row 7, row 7 has 4 different parts, A, B, and C, kind of sub-rows there. And it's all based on how big the body of water is. The bigger the body of water, the bigger sailboat they're expecting. And you can look at those numbers there over on the right. our clearance for a communication or a neutral small body of water is 20 feet, and it goes up to over 40 feet for a 2,000 acres and bigger. And then our phase, I'm sorry, that was our phase wire. Our communications would be C there, 17.5 feet at those smaller bodies of water, all the way up to 37.5 for the large. So remember, those are the worst case seg we have to check those at, not just the day we put it up, not the day that we go out and do an inspection and measure it. The other thing to remember on these is we're talking about the NESC, what its requirements are, its minimums. If you're crossing a river that the Corps of Engineers oversees, you're doing a permit from them, you're probably going to have bigger clearances. That's true of all these NESC Rule 232. If you cross a railroad, you get a permit, you're probably going to have larger clearances. DOT, the city, the county, they all might require more than the code. So just keep that in mind. And then the last part of kind of working with those water areas is the last row there is areas where sailboats are rigged, boat ramps, where all those sailboats are kind of brought into the water. And it says to add 5 feet to all the clearances from row 7. So if we look at that clearance for the 20 acre for our phase wire, 20.5 feet, we add 5 feet to that. So that's kind of the quick answer for clearance of boats there.